We are continuing with summation of series, and in this lesson we're going to be talking about the method of differences. The method of differences is used to find the sum of a series. This method is applicable if the general term of a finite series u sub r can be expressed as the difference of two or more functions. Let's say we have a series represented by the summation from r is equal to 1 up to n of terms of the form u sub r, which can also be expressed this way. If u sub r can be expressed as a difference between two functions, for example, u sub r is equal to f of r minus f of r plus 1, then the method of differences can be applied to find the sum of the series. So we can say, let the summation from r is equal to 1 up to n of terms of the form u sub r be equal to the summation from r is equal to 1 up to n of terms of the form f of r minus f of r plus 1. So this means we can write down the terms of this series. So we start with r being equal to 1, and if r is equal to 1, then we'll be having for this series f of 1 minus f of 1 plus 1, which is f of 2. So we have f of 1 minus f of 2. And that's plus. And now we substitute r being equal to 2. So that will be f of 2 minus f of 2 plus 1, which is f of 3. And next, when r is equal to 3, we'll be having f of 3 minus f of 3 plus 1, which is f of 4. And so on. So the series will continue till we reach the last term when r is equal to n, which is f of n minus f of n plus 1. Now, just by looking at this series, you can see that if we add up the terms, these terms like minus f of 2 plus f of 2 will add up to give us 0. Minus f of 3 plus f of 3 gives us 0, and so on. So all the terms that are in between will cancel out, adding up to give us 0. So the only terms that will remain are f of 1 minus f of n plus 1. So we are saying the summation from r is equal to 1 up to n of terms of the form u sub r will be equal to f of 1 minus f of n plus 1. So in general, when the general term of a series can be expressed as the difference between two functions, then the method of differences gives the summation from r is equal to 1 up to n of the form u sub r being equal to f of 1 minus f of n plus 1. So next we're going to be looking at an example where we're going to be using the method of differences to find the sum of a series. Let's look at it. Use the method of differences to find the summation from r is equal to 1 up to n of terms of the form 1 over 2r squared minus 1. So let's start with that first part. So here I'll say, let u sub r be equal to 1 over 2r squared minus 1. And the goal here is to express u sub r as a difference of two functions. And in order for me to do that, I'm going to break down u sub r into its partial fractions. So here, u sub r can also be expressed as 1 over 2r plus 1 bracket 2r minus 1, which in partial fractions will come out in the form a over 2r plus 1 plus b over 2r minus 1, where a and b are constants. So from here, I can come out with an identity where I can say 1 is identical to a of 2r minus 1 plus b of 2r plus 1. And by the cover-up method, I can be able to get the values of the constants a and b. I'll start by saying let r is equal to a half. And if r is a half, then I'll be having the equation 1 on the left side being equal to substituting a half here for r, we get 0. But if we substitute a half for r here, we are going to get 2b. So we will get b coming out as a half. And also I'll say let r be equal to minus a half. And on the left side, I'll be having 1 being equal to, if r is a minus half here, we will get minus 2a. And if r is equal to minus a half here, then we'll get 0. So we can solve for a here to get a coming out as minus a half. So now that we have the values of the constants a and b, we can substitute them into this partial fraction form that we obtained. So that will therefore mean that u sub r will now be coming out as, in place of a, I'll put minus a half, so that will be minus a half over 2r plus 1, and that's plus a half, which is b, over 2r minus 1. So this is what we'll be having, and we can express this in this form, where I can factor out the half and have inside the bracket 1 over 2r minus 1 minus 1 over 2r plus 1. So this is what we get. So now, according to the question, we want to find the summation from r is equal to 1 up to n of this fraction which we termed u sub r. That's what we want to look for. So I'll say now the summation from r is equal to 1 up to n of u sub r is the same as the summation from r is equal to 1 up to n of half of 1 over 2r minus 1 minus 1 over 2r plus 1. And we can actually have the half factored out. So it's like we're looking for the sum from r is equal to 1 up to n of 1 over 2r minus 1 minus 1 over 2r plus 1. So we can now actually employ the method of differences, since we've managed to express u sub r as a difference of two functions like this. Okay, so I'm now going to list down the terms of this series. So for the sake of space, I'll start from here. I have the half factored out, and I start with the first term. That's when r is equal to 1. And when r is equal to 1, substituting 1 into this, I get 1 over 2 of 1 minus 1, which is 1. And then that's minus 1 over 2 of 1 plus 1, which is 1 over 3. And that's plus, when now r is equal to 2, that's the next term. When r is equal to 2, that will be 1 of 2 minus 1, which is a third. And that's minus 1 over 2 of 2 plus 1, which is 1 over 5. That's plus for the third term. That's when r is equal to 3. So that will be 1 over 2 of 3 minus 1, which is 1 over 5. And it's minus 1 of 2 of 3 plus 1, which is 1 over 7. So the terms will continue to go until we reach the last term. That's when r is equal to n. And if r is equal to n, we'll be having 1 over 2n minus 1 minus 1 over 2n plus 1. Now, if you look at this series, you can see that all the terms that are in between add up to give us 0. Minus a third plus a third is 0. Minus a fifth plus a fifth will give us 0. Minus a seventh, we'll find another positive seventh to give us 0. And so will 1 over 2n minus 1. So we'll only be left with the first and the last terms. So we can say, for our final answer, the summation from r is equal to 1 up to n of u sub r. And remember, u sub r is 1 over 2r squared minus 1 is equal to a half of 1 minus 1 over 2n plus 1. So that's the answer we obtain by making use of the method of differences. So we are done here for this first part. Now the second part of the question goes, deduce the value of the summation from r is equal to 1 up to infinity of 1 over 2r squared minus 1. So what we're looking for is the sum to infinity. So that's the second part. We're looking for the sum from r is equal to 1 to infinity of 1 over 2r squared minus 1. Now, since this is a sum to infinity, and in this case, the limit is no longer n, but it's infinity, then it is going to be equal to the limit as n approaches infinity of a half of 1 minus 1 over 2n plus 1. So this is what we need to find. Now for the constants, we have a half, and that won't change, 1 won't change. But as n approaches infinity, that is, as n becomes very large, this fraction here will turn towards 0. It approaches 0. I'm sure you should know that if we hold the numerator constant and we increase the value of the denominator, the overall value of this fraction will increasingly approach 0. So the limit will be 0 for this fraction. So this can be simplified to a half, and that's the answer to the second part of the question. So that's basically how we handle questions like this.